Hello everyone, welcome to the next biology video. So today we're going to be looking at control of blood glucose and then diabetes as well. So your first little task, what is this organ and what does it do? So first of all, name the organ, and then what does it do? So I want to know what it does in terms of the hormones that it produces. It produces two hormones. Don't get them muddled with enzymes. Okay, two hormones. So if you need a minute, pause the video. If not, we shall carry on. So the name of the organ is check I've got my pen in the right place. Pancreas. Well done if you got that. Fantastic. And the two hormones that it produces, hopefully you got this. Insulin, that's the one that everyone tends to know. And then the other one, glucagon. And they tend to work opposite to each other. So insulin will reduce blood sugar, glucagon will increase blood sugar, but we'll have a look at that in a bit more detail in a second. Okay, well done if you got those. Oh, big arrow there. Right, not only do we need to think about insulin and glucagon, we have this other word, glycogen, okay? And a lot of people get them muddled, so it's really important that we know which is which. So take a minute and just see if you can write a definition for glycogen, and then as an extra bonus, where is it stored? Okay, so pause the video if you need to. Right, let's have a look. So glycogen, not to be muddled with glucagon, which is the hormone. It is a storage molecule, and it stores glucose, which are single molecules, as a long chain of glycogen. So, oops, sorry. Now it looks something like this. Obviously this is a rudimentary picture, but it's all those glucose joined together. Now you might think, well, starch is lots of glucose joined together. It is, but glycogen folds in a different way, so it's a slightly different storage molecule. It can fold up really small. Now, where is it stored? It is stored in the liver, which is the answer that they want in exams, and sometimes it's stored in the muscles, but liver is the one they want mainly. Okay, so glycogen, storage molecule, stores glucose as glycogen, so they join together and it ends up as glycogen. Right, so well done if you got that, and it's stored in the liver. So let's see what's happening with insulin and glucagon. So this is the insulin one. So you're going to eat over here. You decide to eat a sugary meal. So here we've got a cake. And that raises your blood glucose level. So they start to go up. Now this is glucose in the blood at the moment. Now this is what should happen. The pancreas should produce insulin. Insulin will allow the glucose to go into the body cells, which means that the glucose in the blood goes down, even though the glucose in the cells goes up. But that's fine because it can be used for respiration. Right, if all that insulin doesn't get, if all that glucose doesn't get used, then it will be stored as glycogen in the liver. Okay, so we increase our blood sugar, pancreas produces insulin, the blood goes into the glucose goes into the cells, the glucose in the blood reduces, but any that is still in the blood and can't go into the cells will be stored as glycogen. And then that lowers our blood glucose levels. So that's what happens if our blood glucose goes high. Okay, this is in a healthy person. Now, if our blood glucose goes low, so it could be you've been fasting, you're hungry, you've just run a race, you haven't eaten for a while. Okay, your blood glucose levels will go low. So you can see here, low blood glucose levels. So what happens is the pancreas will produce glucagon. Remember, that's a hormone. And when it produces glucagon, the glucagon will allow glycogen, which remember is that storage molecule, to be broken down into single glucose molecules. So it'll be released from the liver from storage and converted back to glucose. When it does that, our blood glucose levels increase. Now in questions, be specific about glucose in the blood, okay? We have to talk about glucose in the blood, because if we don't know where that glucose is, so it's quite important. So just to go once more, low blood glucose levels, pancreas produces glucagon, which is a hormone. That allows the glycogen, so this big storage molecule, to break down into single glucose, and that will raise the glucose levels in the blood. So we need to know all of those things, particularly if you get a 6 marker about glucose control. Now let's just digress for a minute. This is known as a negative feedback loop or negative feedback. What does that mean? Can you write a definition for negative feedback or jot down what you think it means? Okay. So pause the video if you need to. Right. So this is the sort of thing you should be writing. A control mechanism where an internal condition, so in this case blood glucose, changes from a value or set point, and the negative feedback returns those values to the set point. A lot of words. What does that actually mean? Okay, so it means that blood glucose, let's say it starts at 5 millimole in the blood. If it goes too high, we'll get insulin. I'm not going to put all the details in, and it will get returned to 5 millimole. If it gets too low, we'll get glucagon, and it will return to 5 millimole. So the control mechanism, when internal condition, so in this case blood glucose, changes from a value, so this value, this is a made up value by the way, or set point, and the negative feedback returns those values to the set point. So this is our feedback and returns it to 5. Or if we go this way, it returns to 5. Okay, so learn that definition if you're not sure. Another example is body temperature. We need to keep it in a certain range, and if we don't, we've got all these mechanisms to either warm it up or cool it down depending on which way it goes. Okay, so well done if you got negative feedback. Right, we're going to have a little look at diabetes, because this is a big topic. You're pretty much guaranteed to get diabetes somewhere in your exam. Okay, so we've got type 1 and type 2, and they're slightly different. Can you think of the differences between the two types? Pause the video for a second, have a little go, the difference between type 1 and type 2. Okay, hopefully you've had a little look at that. So it's important you know the differences, even though a lot of the symptoms and that are the same. We need to know the difference between the two. So type 1, often the pancreas is damaged. So it could be damaged by your own immune system. That's the most common one. Often found in children. So most children that are diagnosed with diabetes have type 1. It can be genetic. It's not lifestyle related. So it isn't because you've had a very sugary diet or anything like that. It's your pancreas is not working, or it's been destroyed, one or the other. You cannot be reversed, and you will definitely need insulin injections for treatment because you've got no insulin being produced at all. Okay, type 2 is slightly different. This occurs due to lifestyle factors. So we've got diet high in sugar and carbs, lack of exercise, and being overweight, also being over 40 is a contributing factor. Now, these things here, diet high in sugar or carbs, lack of exercise, being overweight, in the exams they call these risk factors. So if it says what are the risk factors for diabetes, these are the things you need to say. And just a little hint, for any topic, if you want to answer you need a better diet or poor diet, be specific. What does that mean? Does that mean a diet low in sugar? Does that mean for heart disease a diet low in fats? Okay, so be specific. Don't just go poor diet because you won't get a mark for that. Right, so people with type 2, they often make insulin, but it doesn't work. They're resistant to that insulin. Okay, now this type can be reversed, and a lot of people, if they get diagnosed with type 2, they can reverse it and get your body out of the state of diabetes. However, if you don't change your lifestyle factors, you might need medication. There's a drug called metformin. You don't need to know the name of it. That's one, and in extreme cases you might need insulin if you can't control it with lifestyle factors. All right, so that's the difference between type 1 and type 2. Right, so let's just, this is a diagram we had before, but let's just have a little look where this goes wrong if you're diabetic. Okay, so you eat your sugary meal, you eat your cakes. Now, pancreas produces insulin. It either doesn't produce it at all, or the insulin you do make is ineffective when you're diabetic. Okay, so either way, whether you're type 1 or type 2, you either won't produce it, or if you do produce it, it doesn't make any difference. So this means that insulin, if it isn't there, it won't allow the glucose to be absorbed by the cells. So if the glucose can't go into the cells, your blood glucose is going to go up and up. Now, some of it can still be stored as glycogen. Because you've got so much sugar, so much glucose, if your glycogen stores are full up, it's likely to be stored as fat or let out in your urine. You're not supposed to have glucose in your urine, okay? But if you do, there's a good chance that you are diabetic. It's one of the tests that the doctors do first off. Then they do a blood test afterwards. But they will check your urine and see if there's glucose in it. And if there is, and you haven't eaten 10 Mars bars in the last 3 hours, then there's a good chance you may be diabetic. Okay, so this bit doesn't happen. So this bit doesn't happen. So some goes as glycogen, some will be stored as fat, and some will come out in your urine. But if your blood sugar goes too high, it can lead to a coma. Okay, and just out of interest, those that you have seen my videos before, hyper, which means lots, hyperglycemia, this is just for a bit of interesting info, is the word for too much sugar. too much glucose in your blood. Okay, so if this happens, this person, and if they end up in a coma, they're likely to need an injection of insulin to try and bring it back down again. All right, so I hope that makes sense. Let's have a look at an exam question. We love an exam question. Okay, pause the video, take a minute to read it, and then we'll have a look. Okay, so this one is all about eating bread. And they ate 2 slices of white bread, and then on another time 2 slices of brown bread, and another time 2 slices of wholemeal bread. Now, it doesn't mention diabetes here, so we're going to assume that this lady is fully functioning with her insulin and everything. We're just changing the type of bread to see what happens. So the blocked line is, I'm just going to put it on there. This one is white bread. The little dots are brown bread, and this one is wholemeal bread. Okay, let's have a look at the question, then we'll come back and look at the graph. Describe the effect of eating 2 slices of white bread on the person's blood sugar concentration. Okay, so the first thing you're going to do, and I always encourage you to do this with any graph in any science, have a look at the scale so you know what's going on. We've got millimoles per decimeter cubed, and it goes from 5 up to 8. So each one of these will be 5.1, yeah, 0.1. So when it's describe a graph, we're just going to say what we see. Okay, we're describing, we're saying what we see. So for white bread, the blood glucose concentration increased. It started here and it peaked up here at 7.9 millimoles, and that was at in between kind of 60 and 80 minutes. And then I stayed the same there for a bit. And then it dropped back down to 5. Now, when you describe a graph, what we're trying to do is describe a graph so that someone else could draw it or draw the shape of it. So, describe the effect of eating 2 slices of white bread on the person's blood sugar concentration. Right, so the blood sugar concentration, I always try to get you to write that rather than it. If you write it in a question, it's a bit tricky. The blood sugar constant, I'm just going to write conc for concentration, increases from 5 millimole to, I think it was 7.9. And stays there because we've got a flat bit on top of the graph. From, I think it was 6, you can probably see it a bit more accurately, 60 to 80 mins. Okay, so if someone else was trying to draw this graph, they can say, well, it goes up and then it stays flat. What does it do now? It then decreases back to 5 millimoles by 120 mins. Thereabouts. So the person, okay, right, so we know it goes up, goes flat, and then it goes down. Okay, so they can see the general shape. That's what we're trying to do when we describe a graph. Right, wholemeal bread would be most suitable for a person with diabetes. Explain why. 3 marks. Okay, let's go back to our graph and see what's going on with wholemeal bread. Okay, so wholemeal bread is this one here, and it peaks at 6 I'm going to say 6.7, although your eyes are probably better than mine. Okay. Right, now what the question hasn't told us is anything about diabetes. So we have to assume the examiner knows nothing, and we're going to pick up those very, very obvious marks. Okay? So, wholemeal bread would be most suitable for a person with diabetes. Explain why. Right, let's go here. What do we know about diabetes? People with diabetes cannot control their own blood sugar because they don't have insulin. But it hasn't told us that anywhere in the question, so let's put some of it in our answer. So diabetics do not produce insulin or cannot control blood glucose. Okay, now I always say state the obvious. Okay, because it's very easy to slip into the wholemeal bread but not say about diabetes. So diabetics do not produce insulin or cannot control blood glucose. So wholemeal bread only raises glucose to, was it 6.7? Okay. So less insulin is needed to reduce blood glucose. So actually that question, because it's explain, where it's explain, we need biology words get biology prizes. Okay, so although it is about wholemeal bread, that's only a small part of it. Okay, we need 3 marks there. Okay, hopefully that was useful, and I will see you all in the next video. Take care, everyone.